Hi, I'm Mr. Peacock, and today we're going to talk about solving exponential and logarithmic equations. So, in order to solve exponential equations, we turn them into log equations. Then we need the change of base formula. And the change of base formula is this. Log base b of m is equal to log of m over log of b. Now, if you have a TI-84 or so on, it will actually do change of base for you. But if you are using a TI-83 or some older TI-84s that haven't been updated, you need this formula. But I'm also going to be honest with you here. Even if you can do log base whatever in your calculator, this is faster. And so you should learn this anyway. So log base b of m is equal to log m over log b. So let's try this out a few times. So this says log base 3 of 42. So what we're doing here is we would do log of 42 over log of 3. So if you would please, I would take out my calculator like I'm doing right now, and I would say log 42. Oh, one very important thing to do is note that when you're putting it into the calculator, it will look like this. Log parentheses 42. Make sure you close your parentheses. If you don't, you will get the next part wrong because you would accidentally just be doing the log of 42 over the log of 3, as opposed to the log of 42 over the log of 3, where they're separate. So, log of 42, close parentheses, divided by log of 3. And what you're going to end up getting is 3.402. Okay, so let's try this one. Log base 12 of 8 is the same as the log of 8 over the log of 12. Notice in this case you're having a smaller log on top, which means it'll just be the decimal, no whole numbers here. So, log of 8, close parentheses, divided by log of 12. So what you end up getting is 0.837, or 0.84 if you're rounding to the nearest hundredth instead. Alright, so now that we've done that, let's try this. 7 to the 3x equals 20. So what we're trying to do is solve these exponential equations, but the problem is that our exponent is up here is where our variable is. Our variable is in the exponent. So to get the variable out, we have to go to its inverse, or the logarithmic function. So we're going to rewrite this equation. So it would become log base 7 of 20 equals 3x. So first we have to figure that part out. So log 20 over log 7. So log 20 in parentheses over log 7. That gets us the number 1.53. You know what? 54 once we round up. So is approximately 3x. At which point when I divide by 3, I end up getting 0.513 is approximately x. Okay, so now let's try this one. I would say log base 3 of 101 is the same as x plus 4, which means the first step is to do log 101 over log of 3. Log 101, close parentheses, divided by log 3. And that ends up being 4.2. It's 4.2, well, actually 4.201 if we round to the next number. And that is equal to x plus 4. Meaning, to get x by itself, we just subtract 4 from each side, minus 4, minus 4, meaning 0.201 is approximately x. Okay, so now let's try this one. It says 10 to the x equals 19. So what I would do in this case is I'd just start out by writing log base 10 of x equals 19. But in this case, remember, log base 10 is the same as me just saying I rewrote this in the wrong way. Why did none of you tell me somehow over the internet before I recorded this? Very disappointed in all of my students. So log base 10 of 19 equals x. But here's the thing that I was trying to say. Log base 10 is the same as just writing log of 19 equals x, meaning all I have to do here is do log of 19. And that means that x is approximately 1.279 when you round. Okay, so now let's try this one. Remember, we would do log base e of 37 equals 2x plus 1. But rather than doing log of 37 over log of e, in our calculators we already have a button for the log with the base of e. The button is ln, which once again stands for natural log. It's Latin. That's why it seems different. So ln of 37 equals 2x plus 1. So let's see. ln 37 is 3.611 approximately. And that equals 2x plus 1. So my first step is to subtract 1. That means 3 becomes 2.611 is approximately 2x. Then I would divide by 2. And I would get 1.305 is approximately x. If you're wondering why I'm not saying 306 when that would be 55, it's because I'm still using the original answers in my calculator and dividing from them, rather than going in and just putting in my rounded number each time. I do not actually round, even though I'm showing rounded numbers, until the very end. Okay, so now let's try this one. Now you might go that the first step is to write log of 5e, but that is wrong. The fact is, if you're thinking that, you're not realizing that 5e is two separate numbers, two separate terms. So what we have to do first is divide by 5, because 5 is not being raised to the 6x plus 3. So this means e to the 6x plus 3 is equal to 0.02. At which point I rewrite this as the natural log of 0.02 equals 6x plus 3. So natural log of 0.02 ends up being negative 3.912 is approximately 6x plus 3. My next step is to subtract 3. So that becomes negative 6.912 is approximately 6x. My final step is to divide by 6 on both sides. So when I divide by 6, what I end up getting is negative 1.152 is approximately x. Okay, now let's try this one. This one may seem weird to you because you might see a natural log, but it's in the exponent, so our first step is just what it normally would be, which is to rewrite this as the natural log of 20 equals the natural log of 5x. Now there are a lot of things I could do, but honestly I don't need to, because what I'm noticing is the natural log of 20 is the same as the natural log of 5x, which means 20 has to equal 5x, no approximates or anything, then I would just divide by 5, which means x is 4. Not about 4, it is 4. All right, so now let's do our last part where we are solving each logarithmic or natural logarithmic equation. So this one says log of 3x plus 1 equals 5. So just like when we were solving exponentials, we had to go to logarithmic. When we're solving logarithms, sorry, didn't mean to go up into a question. When we're solving logarithms, we have to write it as an exponential. So if I don't see a base, remember the base is 10. So the rewritten version of this is 10 to the 5th. Ooh, let's rewrite that. 10 to the 5th equals 3x plus 1. So I just rewrite this as 1 and then 5 zeros. So 100,000 equals 3x plus 1. I would subtract 1. That means 99,999 equals 3x. And I have 99,999 problems. But this is not one of them because all I would have to do is divide by 3. Which means my final answer is just 33,333 is x. An easy, small number for all of us to use. Okay, let's try this one. All right, you remember earlier we had 2 and then like 5 times e to something. Well, this time we have 2 times log x of equals -1. Now, I could try to write this as log of x squared, but honestly, I'm just going to solve this like I normally would and divide by 2. That means the log of x is equal to -1/2. Then I just write 10 to the -1/2 equals x. Now, let's remind ourselves, if it's negative, that means it's going to be in the denominator. So that means 1 over. But 10 to the 1/2 is the same as the square root of 10. And that would equal x. So you might go, yay, we're done. All of our answers are complete. But remember, I don't like radicals in the denominator. They make me sad. They make me kind of want to cry. And I just can't do that right now. I'm sorry. So because of that, I'm going to multiply the top and bottom by the square root of 10, which will rationalize our denominator, meaning our final answer is the square root of 10 over 10 equals x. Okay, so now let's look at this one. Once again, we want to get the log or the exponential equation by itself each time. So this time you'll notice it says -3. So our first step is to add 3 to both sides, which means log base 2 of 6x is 1. So 2 to the first power is 6x. Now 2 to the first power is just 2. So divide by 6, divide by 6. 2/6 is the same as 1/3, which is x. Okay. So now this says natural log of 15x equals 4. So I'm going to rewrite this, but remember our base if it says natural log is e. So that means e to the 4th is equal to 15x. So our only step is going to be divide by 15. And I'm going to do that before I do e to the 4th because when I can wait until the last minute to have our long irrational numbers, I will, to be perfectly honest. So what I'm doing here is I'm just writing e to the 4th, making sure I close my parentheses, and then dividing by 15. And what I end up getting there is 3.64 is approximately x. All right, let's try another one. Now you might go, oh no, we're adding. So I guess we subtract, but remember, there's another rule that we can use. If you look at literally the last lesson, if I remember to, I'll probably put a little link on the bottom, but if I don't, it'll be at the end of the video for sure. In our last lesson, we talked about the rules of logarithms. And one of the rules was the product rule. And in the product rule, we said that if we add one log to another log and they have the same base, then it's like the numbers that they're of are going to multiply. So in this case, these both have a base of e, so it's going to be like x times 4, meaning we could rewrite this as log natural of 4x. It's going to equal 2. So at that point, I just rewrite this as e squared equals 4x and divide by 4. So now I'm just going to put that into the calculator. E squared divided by 4. And that ends up getting me the answer of 1.847 is approximately x. All right, so let's try this one. Our first step is to divide both sides by 5 because it's 5 times the natural log. So this ends up being the natural log of 3x minus 2 is, in this case, 15 divided by 5 is 3. So I'm rewriting this as e cubed, or e3. E cubed is the accurate one. E3 is the fun video game conference that happens in July. It's apparently a nightmare to be at. E cubed is 3x minus 2. So in this case, unfortunately, I do actually need to first figure out what e cubed is. It makes me very sad. So this ends up being e cubed is 20.086 is not equal to, but approximately 3x minus 2. So my first step would just be to add 2 to both sides. So this ends up being 22.086 is once again approximately 3x. And then I just divide that number by 3. And what we end up getting is, let's see, we end up getting about, give or take, looks like 7.362 is approximately x. And that's it for today. Like I said earlier, if you're wanting to remind yourself about some of the rules of, for instance, logarithms, those are all going to be in the video that I have right around here. Also, if you would please like and subscribe, and feel free to watch any other videos that you may need. Have a wonderful day.